we saw the PQC and QKD part. We covered the PQC and some limitations, and next covered with the QKD part and the QKD communication scheme. After that, we saw the limitations of the QKD. Point to point one, it is one limited distance and less key rate and all other things. And it is not mainly it is not able to integrate with the conventional and current systems. It is not able to scale, and it is not able to control centralized. It is not able to establish a network. So the next we focusing on the SDN part. SDN is capable of making the complex networking, rerouting, and many centralized control features. So we introducing the software-defined networking to the QKD system, combining the QKD with the SDN for using the QKD system as a network, able to integrate with the conventional systems, and also able to relay the keys between the nodes, also capable of doing the PQC. Coming to the STQKD architecture, main is the QKD layer is there. It is a layered approach. You can see in the many documents, you can see difference in many papers and documents. But it is on the major architecture part, the layers are the one is the QKD layer, the quantum key distribution part, underlying part is there, and it's the quantum communication, which is considered as a layer. Another one is the controller layer. That the control lanes means the SDN controller for the management of keys and rerouting and all other applications. Another one is application layer part, and another one is the network orchestration part. These are the basic QKD architecture. You can see in the another architecture in another, say, some layers may be there. For the STQKD architecture is also different, but only mandatory layers are there: the QKD layer and the controller layer and application layer. Some documents say that the controller and network orchestration layers are clubbed one. Some vertical layers are there. Some is the horizontal layers are there. The use cases of STQKD use cases. It is for the critical infrastructure, suppose the military communications or smart grid communications. After the introduction of the quantum computers, we can use. Otherwise, some other third party can down the entire power grid infrastructure. The financial security is another part. Secure banking and stock exchanges, the crypto wallets, securing the crypto wallets also. And the healthcare part, it is also a good one, and the government and military. It has many uses. Presently, the machines are, the quantum computers are in the market, but it may take some more time to break the PKI infrastructure. In future, after 5 or 10 years, it definitely will break the PKI communication. That will affect the all infrastructures, including financial, healthcare, government, military, and the critical power infrastructure also. Then the software-defined QKD network, SDQKDN. Software QKDNs, the SDN to quantum key distribution network. The SDN capability is adding to the QKD. That is called the software-defined QKD network, and it manages the quantum and classical communication channels, optimize key distribution, and integrate QKD with the existing or future secure communication systems. There are many features, their responsibilities for the STQKDN part. It is able to communicate or able to manage with the quantum as well as classical channels. Also, able to distribute the keys, integrate with the QKD with the existing future secure communications. Another one is the centralized network manage. One centralized controller is able to manage the entire network, also the network status. In one dashboard, you are able to see which QKD nodes are up, with which path is provisioning now. The Kuber rate, you need to find it out from the network. Also, you are able to establish the secure channels. You are able to get the keys using the existing APIs. Also, it is also possible using the SDQKD network. And the scalability of the network, we are able to introduce the new channel and quickly also able to make the complex network solutions. It is able to support the hybrid systems and it facilitates the diverse QKD protocol. It is also able to suppose three parties are there, Alice, Bob, and then Alice at another part. One party is Alice to Bob is communicating with the BB84 protocol. Another one is from B2C is communicating with the DPS protocol. And the protocol is different, but it is the controller and the QKD network should be able to communicate between these nodes to another Alice to another Alice using the Bob node with the different protocols. Also, it should reflect the monitor that eavesdropping attempts. Sometimes Kuber is going high. It should also notify to the users. And the SDN programmability enables the rapid response to threat. Also, some threat is happening. The northbound and southbound interface of the SDN controller is communicating with northbound to the application and the southbound to the QKD layers. The controller is most powerful in the SDQKD network. Coming to the software-defined QKD stack, you can see the SDN controller is communicated to the QKD nodes. Many QKD nodes and the QKD nodes, there are many layers are there, transport layer, network layer, link layer, physical layer, or similar with the OSI layering part. And in addition to that, the SDN agent and secure information base is a vertical layer. Is able to access directly from device to the transport physical layer to transport layer. Another one is the SDQKD with the PQC. I already mentioned that SDQKD is able to introduce with the PQC. The PQC part is why it is important. More important is some devices we are not able to communicate. Some device may be very low resource power, like the IoT systems. There is no hardware capabilities, not able to communicate with the QKD node, or not able to link with the QKD devices. Those devices we are able to communicate with the PQC. That PQC will supported by the SDQKDN controller. And this one is the one extended architecture. It is only for the reference one. The extended architecture means in the lower part you can see the PQC based link. It will support the PQC also, and traditional network it is supported also, and the QKD network is there. QKD network is communicated with the free space QKD through the air or the satellite to the another one, and all things finally will connected to the data center, and the SDN controller is overlooking all these activities. And the SDN controller is connected to the application layer. The application layer. The application layer is the users are interfacing with the application layer. Application layer is communicating with the SDN controller. The SDN controller will communicate with all other underlying devices, links, PQC, gear link, direct point to point, and it is able to communicate with the data center. This is as a virtual QKD network. As a service, we can also provide this as a service. The SDN controller we can provide as a network service also. And coming to our development part on the CDAC side and the IATM sides, we have partnered in the development of SDN QKDN, SD QKDN controller, mainly in the software side, also in the hardware side. Also, we have collaboration with IIT Madras, SAIS, and ARNET for the development and implementation of SD QKDN network. It is named as the Metro Access Quantum Area Network. It is short named as the MACA. For the development purpose, we initially created an SD QKDN simulator. The simulator purpose is that suppose the initial phase of the development, there is no network, actual network for testing all the features, all the quantum communications, all not there. In the initial part, we did the simulator for quantum transmission, classical post processing, and integration with all those things for the testing and purpose. Testment. After that, we developed using this STQKDN simulator. We developed the STQKDN controller and management application, and then the same application is based on the ETSI and ITT standards and ported to the existing network. Coming to the STQKDN simulator part, it is an integrated one because we need classical and quantum channel. Here for the STQKDN simulator, we use the NS3 for the classical simulation. All might have familiar about the NS3 network simulation network simulator. It is for simulating the network protocols and applications and other things. Here we used the NS3 for the post-processing steps in the QKD. And the NESCUD is for the quantum simulation. For the generation and creation of the qubits under the simulation software, we used the NESCUD. It is used for creation, transmitting, and for safety also. And the communication we use, the REST-based communication is used for this NS3 to NetScoot and NetScoot to SDN controller and to the management application. Here also we used the symmetric key encryption using the Chacha poly to ensure the security of the REST-based services. The data format we used is the JSON and supports the emulation also. Emulation means that the controller is in the real world. The simulator software can interface with the real-time machines. If suppose we are using in the simulation board, that will do the work in their time frame and it will not communicate with the real world system. Using the emulation, the integrator SD QKDN simulator can communicate with the real world systems, real systems, a real controller installed on the outside network, and also developed the capabilities of pluggable post-processing algorithms and integrated the SDN agent and the key manager. Coming to the network stack part, the lower QKD device part, we used the quantum transmission channel using the NetScoot. Another part, we used the classical device. We used the NS3 for the classical device and key storage. Both that in the MAC layer introduced the authentication and post processing. The QKDN manager and key manager are vertical layer placed in that. Above that, the external BSC sockets based on the libraries created and the libraries used by the SDN agent for the communication. It is based on our research only. And the simulator communication, in going to the detail, in a node, we have NetScoot node is also there. The NS3 node is also there. Both are communicated using the REST and JSON data format. Both are communicated as a node A in the quantum simulator. And the other part is also, both side it is also there. And both are communicated from NetScoot to NetScoot is communicated, connected via the quantum channel. Actual quantum transmission is happening through this one. And the classical channel is connected to the IPv4 using the NS3 and both are communicated. For the RESTful service, we use the Chacha-Poly algorithm and the base 64 encoder for the transferring through the HTTP. This one is the one use case. It is already deployed in the Chennai area, the metro area Random Access Network. It is short named as MACAN. It includes many modules, including one. Here, the topology you can see that the A node is in the IIT Madras is physically placed there, and another one is MAT in the Chennai itself, and another is in the sets. Two nodes are in the QKD nodes are in the sets, and another is the multiplexer is there, and the last one F is in the NIC or in Chennai. These 5 QKD nodes are in the 5 different offices deployed at Chennai and connected through the optical channels. The QKD links and classical links are established using this one. All nodes is communicated to our SDQKD controller. Suppose when the device A is up, it will be notified by the SDQKD. The A is transmitting to the B, it is also reflected on the SDQKD controller. Many communications is also there. Suppose one application is there in the A, connected to the A, and another application is connected to the application B in the node F. I need to communicate A to F. Then I will inform this node to communicate from A to F node. Application A to application B. Then the controller will provision the path of based on their path computation A, B, C, E, F. And the communication key will be generated on that path, and the communication will have. Suppose on the sometime I think the C2E path is broken, then the controller will be routed to the A, B, D, E, F. This will happen, and this all informations, all provisioning will happen in the SDQKD controller. One management application is also there that is interfaced with the SDQKD controller. This management application will shows all node status, node logs, and all notifications, events, logs, everything. It will be notified. This one is the test one for further details. The first one is the controller. I already mentioned that the controller is connected to the QKDN manager. It will shows the topology and other things. Coming to the nodes, 3 entities are there. One is the SDN agent, and another one is the key manager, and it's the QKD module. It is the hardware module and firmware. And coming to the interface type and specifications, these specifications are coming from some standards coming on the next slides. All communications are REST based, and another the data format is JSON and is encrypted. Also encrypted using the CHA-20 Poly 131, which is lightweight and commonly used in the embedded systems. And another one is the basis for encoding for transferring through the HTTP. In the agent to controller, in the right side, you can see one communication from agent to controller is there. Then first one data is using JSON data format is used. Chacha Poly encrypted, base64 encoded, and then passing to the REST. And on the right side, base64 decode and Chacha Poly decrypt, and then we'll get the JSON data to the controller. This is the communication key. The authentication is also happening through this one using HMAC authentication and one SDN agent to controller. The initial authentication is there. Initial authentication means that suppose we are starting the communication from one device to another device. We are not able to use the public key infrastructure. So initial communication is happening through the pre-shared key. In the SDN agent part, we are providing a pre-shared key also. The same pre-shared key is available to the controller part. It is pre-shared, not transferring to any other classical channel. We are basically providing the key for the initial communication. Using the initial symmetric key, the ciphertext is generated and the authenticated to the network and passing through this one. In future, after the future communication, we can use the quantum transmission keys. Coming to the standards for SDN agent and key manager, the ITUT standards are there, ETSI standards are there. For the quantum key distribution, QKD application interface, the detailed information is provided, detailed design is provided for that. For the protocol and data format was-based key delivery API, the ETS QKD 040 refines that the standards of APIs that exactly define the key value pair in the format which is specified as the communication protocol or method is posed, and also passing the QKD also. In final stage, I can show this standard format also. Another one is the quantum key distribution control interface to the software defined or ETC standards also there, which is also we referred we adhere with these standards for the development of SDN agent and key manager also and control also. Coming to the ITUT standards, many key distribution standards, ITUT 3800 is there. We are focused mainly for the control and management. ITUT 38004 is used. There are many standards are there for the software defined networking control also. We need to develop software based on these standards. Then it will be ready for the interoperable. Suppose one QKD network is also there, another vendor can provide another QKD nodes. We need to communicate from one vendor to another one vendor, then we need to adhere these standards. Otherwise, it will not communicate with the different or QKD devices from the different vendors. We also found the NIST white papers on PQC and OQC library for the integration of PQC to the control process. Here, one sample management application I mentioned in the Macan. The development is all over. On my previous project, it was you can see the nodes, communication schemes, and nodes name, nodes IP, and all other parameters. You can see Kubernetes and the methods also there. It will display on the management application. Coming to the key store, suppose we are in the Alice 100 ATM node, we can also get the key pair between Alice to Bob and all parameters 160 byte keys. Now, presently here, key store size is also mentioned. Two keys are delivered, consumed, and all the details will be there provided on the management application. This data is taken from the QKD device using the ETSI standard APIs. Coming to the key manager is the one of the most important module in the STQKD part. One is the key generation and its collection. Key generation, key manager, suppose I want to communicate from node A to node B. Then I initially communicate with the key manager. I need to communicate with the node A to node B. Then key manager will initially check for whether key is available on the A to B key pair. A to B, key store of A to B. If it is not there, then it initiates the generation of keys. Then the quantum channel will be up and generating the key and the collecting the key in the key store, and based on the key requirement, they distribute
Sir, your voice is not audible.
Dear participants, please stay connected.
Am I audible now? Yes, am I audible now?
Yes, sir.
Hi, sir.
Yeah. Meanwhile, I think I lost the connection or something happened. From the slide, you,
Yes, visible, sir.
I have completed. Yeah, I can once again start. Yeah, the key manager part is responsible for all activities. The key generation and collection, key storage and management, key distribution and allocation. Here, the key manager is the critical role in the STQD network. First one is the generation and collection. Suppose one party, Alice to Bob communication is happening there. One application connected to the Alice is asking keys to get the communication of the Bob node. Then initially it informed to the key manager. Key manager will check in the key store whether the keys are available or not. If it is not there, it will initiate for the generation of key. And then the storage of key. After the generation of the key manager should collect the key and store the key in the key store. And it is also able to distribute the keys. Suppose many applications are connected to the Alice nodes. Then the application should able to collect corresponding keys. Suppose one node is connected to the Alice. Many applications are connected to the Alice nodes. Two, three. One is video, one is audio, one is image. And the other side is also that there many applications can be connected to the one application, one node. Many applications can be connected to the each node. Then the key manager able to distribute the corresponding keys, proper keys to the corresponding applications. Also, it should integrate with the SDN controller, and it is able to interface with the application through the APIs. ETA standards are there. Standards provide the exact key delivery for the secure communications. And the schema also resides in the SDN control part, communicate with the coordinate nodes and calculators. It is able to manage, store, distribute cryptographic keys in order to the quantum key distribution. In some applications, we can specify the life cycle of keys. Suppose I need to go with a high priority task, high priority communication. Then I can use the live key. The key can be generated instantly and can use. For the low priority task and low priority application, we can also use the existing key or stored key. Also, we can place the keys generated after 1 hour should be expired. That is also possible. That should be ensured by the key manager. And key provisioning, it is also possible through the key manager. And the secure storage of keys. Keys can be stored in secure. For some application, we need not want the high priority security. Then we can use the key. Even we can use the storage of keys in the RAM or the file. Another one is we can store in the TPM trust platform module. And another one, if you need the high priority task, high security, then you need to provide the key in the HSM hardware security module. It is also possible with the key manager. And the implementation of all the standards. The key delivery part, it is provided the well-defined and well-documented documented standards there, pointing to the methods, pointing the URL, pointing to the JSON data format also, and the key format also. They are mentioning all the type of key, format of key, everything is specified by the ETSA that we need to have here. Yeah, before going to the interoperable STQKDN, we talked about the game ETSI, some architecture, STQKDN simulators, and communication mechanisms on use case, metro area quantum access network, and applications and working. it is for the large scale deployment. But this one, we are focusing only on the specific networking of a single vendor. And for the deployment in the nationwide and all other things, we need to communicate with the different QKD networks. And also to the, suppose QKD solutions are provided by many. In India, there are metro access network is field deployed network is also there. For the CQN is there from the C road that communicate using the different protocol, but we need to be interoperable. One thing, how we can make interoperable. One, through we need to adhere the development of key manager, controller, and agent through the standards only. Suppose one party, one vendor is adhering to the ETSI standard, another party is also obeying the ETSI standard, both can communicate. In the diagram, in the top total 7 nodes are there. The top 5 is the first one is the this part is the Macan part, and this lower part you can see 2 nodes in the 1 at C node and 2 at C node. It is the CQN node. Then we need to interoperable between these 2 nodes from the Macan. Suppose I have an application from Alice 1 at ATM. I need to communicate to the application in the 2 at 0. How it will happen? Using the interoperable SPQ client, it is possible because in the dotted block, we have a co-located nodes are placed there. This 1 at 0 nodes and Bob at nodes are co-located in the same place and connected to the secure classical gateway channel as some draft documentations are available on the ETSI standard. It is not completed or not finalized. Some drafts are there. Based on the draft, we prepared some interfacing mechanism for communicating from this to this one. And using this communication interface and the protocols, we are able to establish key transfer between this Macan node to the CK node. Similarly, we can place another vendor nodes also. This is on the interoperable STQKDN part. And another one is the part, the quantum internet. Here we mentioned about the initially with the QKDN network and then interoperable QKDN network when the multi-vendor is also discussed. And next one is the providing the quantum internet with local access. This is one of the project from the National Quantum Mission in Guam to build India's own quantum internet network. Because in China and European countries, Japan, they have similar QKD networks up to 2000 kilometers with the trusted nodes. The main aim is to initially secure the military infrastructures and then providing for the high critical, mission critical applications. And finally, it can go for the common people. Common people will not happen in recent, but it should be there in the future. In this project, we are presently implemented the quantum key distribution network from Chennai to Bangalore, which is already implemented. They plan to extend this Bangalore to Delhi using the Hyderabad, Bhopal, Indore, and providing the secure trusted nodes and best relays in the between places. Because QKD has a limitation in the distance, then they recently implemented the trusted nodes and endpoints are there. It is proposed. It is the full work of this Bangalore to Delhi will be completed within 4 or 5 years, I think so. The Chennai to Bangalore is already done, and other major infrastructure is going on this way. It is the network with the dedicated hardware and dedicated cabling and infrastructure. Before going to the finalization part, we can see the organization involved in the QKDs. One is the National Quantum Mission, or might have familiar word. they have huge resources and huge funds for the content development because it will be a threat on in future. Most of the countries like China, Japan, US, Europe countries are focusing on the development of QKD networks for the military and power grid communications, secure communications. The ISRO is also successfully tested the free space QKD. That is, QKD, instead of using the optical cables, they use the space of the photo transmission. In IIT Delhi is also part. Tata Institute of Fundamental Research is also doing, and the PRL Physical Research Laboratory is also focusing on that. Raman Research Institute also looking with the free space QKDs. CROT is also there, and Indian private companies. QNU Lab is one of the private player in India. They have QKD devices, and they have QKD devices in the market. We can also able to buy and we can do the research. And they have their own PQC quantum stacks and random number generator, true random number generator is also there. And DRDO is also doing the research in the QKD part. Then the future of secure networking, counter-safe networking, STQKD offers unmatched security and flexibility. For the implementation of nationwide interoperable multi-vendor communication with the centralized control and management, we need to focus on the STQKD. The STQKD is offers the unmatched security for the internet. It is a feasible solution for the secure communications. It can provide the kind of secure networking future also. One thing, the first quantum era, we need to focus on the PQC for the IoT devices, lightweight devices also, and explore the QKD option also because the PQC is not proven yet. And in future, some algorithms which is capable of running on the quantum computers can break the PQC algorithm. That may happen or not. Sometimes it may not. But also we need to go for the option with the QKD also. Also you need to watch the quantum advancements and update defense regularly. For the other countries are adopting many other things in the future. Some countries may not reveal their capabilities of quantum computers because it is part of the secure and they need to break other communication from other countries. But we need to be defensive the security. We need to watch closely and and monitor the situations, scenarios in the world. Now, one side, closing the presentation. After the closing this presentation, I can show some standards documents. Just looking the standards and some PQ open counter safe website also. One is the open quantum safe. This one is the one project name I already mentioned, like that, the Open Quantum Safe project. You will get the post-quantum cryptography materials here, and you can able to download the library, libOQS library. You can also download. It is available on the GitHub. Using this API, many revisions are there. You can also use this libOQS on the GitHub. You can also installation instruction is there. The C library is there, and it is supporting algorithm key encapsulation algorithms and signature schemes. Many are there. It will support all of the things. Using this key, you can generate the keys on your own computer. There is no other infrastructure is required. You can make this one instance a single Linux machine. And the some benchmarking of algorithms is the benchmarking means that some of the algorithms you are not able to run it on the lightweight devices. In the for the IoT,
ಸರಿ ಸರಿ ಸರಿ
yeah,
ಸರಿ
yeah. Another one, this one is you need to refer for this one open content safe project. Another one is the NS3. You just look on that. This one is the classical simulator, network simulator is there. You can download the versions.
ಸುಲ್ತಾನ್ ತಪ್ಪಿದ್ದಾ?
Yeah, you can use the
Sultan.
latest one.
సుల్తాన్ చెప్పు ఎక్కడ
You can use.
హలో సుల్తాన్ చెప్పు
You can go for the searches. You will get the documentations here. You can install and develop the simulation programs using this NS. Another for the quantum key putting is NetScute. This one the NS3 is the C++ based. This one is the NetScute is the Python based. You can go with this one is the tool for the quantum network design. Based on that, you are able to create the qubit, transfer it, and you can measure it, announce it also. It is also possible. The code snippets are there. You can also implement it. You can also install it on your machine. And forums and documentation is also there. Everything is there in the another one is the standard document you referred. One is the ETSI documents are there. This one is the application key interface. This document refers to the communication methods, key synchronization, and all other documentation are there. The parameter names also introduced. And this one is the key delivery, REST-based key delivery API from the ETSI. In this document, they have introduced some SAID, some other design terms are there. Then they provide the communication scheme and format, everything is there. And they're coming to the protocol. They are providing with the method of get or post and the host name and URL, and everything is provided there. You need to write code based on that. So they have provided the JSON data format for the key management, get key, provisioning the keys, and the getting the data format. They are providing like that. For the getting key also, they have provided this one. The key ID is there, what are in the UID format, the key type is there. Everything is there in the format. Also, this so for the content distribution for the SDN part is also covered. Design aspects are there. The scheme for the application registration and other communication procedure is documented, well documented here. Based on things, we are able to develop the application and communicate with the multi-vendor. For the IQT standard is also defining some global standards for the control and management for the content distribution network. Apart from that, many other documents are there related to this. This one is the providing with the quantum layer, key management layer, and QKD controller layer, cryptography application layer, and the management layer and use many layers and divisions classifications are also provided by this one. Documents are there. Based on the document, we can write and develop the applications. Any other doubts? We can discuss.
Sir, there are two questions posted in the chat box. Shall I read it?
One second, pardon. Yeah.
First question is, can quantum key distribution bridge the trust gap in end-to-end encrypted communication?
Hello. One second. It's not properly audible. One second.
Okay, sir. Can quantum key distribution bridge the
Yes.
trust gap in end-to-end encrypted communication?
Yeah. It can provide the gap, but it may not happen in the near future. That may take 5 to 10 years. Because the PQC is most popular, we can adapt it for all communications.
Okay, sir. The next question is, how does software ensure synchronization between sender and receiver in quantum key distribution?
Yeah, it is a good question. Actually, for the implementation side, the quantum synchronization is happening through the certain hardwares are there. The synchronization for the clock synchronization hardware. For our deployment, some external devices are there. Important devices are there. Also some, I think, some local devices also there. Using the devices, the clock synchronization will happen using the device only. There are many other designs. There are many features are there. Some white rabbit network, white rabbit is also there for the synchronization part, but it may not be usable for the large scale deployment. I think it is for the research works and all. Some proprietary tools are there. Some of them are available. We need to import it from the outside country also. Some restrictions may be there. We can use the available devices. Also, some resources are there. We are able to develop the physical devices also. Presently, for the network, it is using by the third-party components.
Okay, sir. Dear participants, if you have any questions, please post them in the chat box or unmute your call and ask.
Yes.
So I think there are no more questions. Shall
Yes.
we go on to the next session, sir? What are time?
Yes. Yes.
Thank you so much, sir, for your enlightening section and for providing a deep insight into the quantum key distribution. Your contribution has helped us to understand the real world implication of quantum computing in the real world of secure communication. As we come to close to the FDP, I would like to take a moment to thank all the resource persons who have contributed immensely over the past 5 days. A heartfelt thanks to our respected principal, Dr. J. Mageshwaran, and the management of St. Xavier Catholic College of Engineering for their constant support and encouragement. I also thank the organization member, faculty, participants from academia and industries, and our technical support team for making this FDP a grand success. Let us continue to collaborate and share knowledge in the future as well. Thank you all.
Before we conclude today's session, I would like to share few important details regarding the issuance of certificates. All participants who have attended the sessions regularly and submitted the feedback form will receive an e-certificate of participation. We kindly request you to fill out the feedback form shared in the chat box. This form is essential for processing your certificate. Please make sure to enter your full name correctly as you would like to appear on the certificate. Provide a valid email address for receiving your e-certificate. Submit the form by today by 1 p.m. The certificates will be emailed to you within the next few working days. We truly appreciate your participation and hope you found the session valuable and insightful. With this, we officially conclude the Faculty Development Program on Quantum Computing and its applications. Thank you all. Have a wonderful day ahead.
Thank you.
Hello, brother.